Hey guys, welcome back to the shop. We're going to jump back into our Hardtail Vise build here, and I want to go ahead and work on this dynamic jaw body and see if we can get it finished out. So just to recap, we've already got all of the other surfaces machined on there, and what I've got left to do is to finish out the two sides. So we've got this side right here to mill, and then the opposite side we've got to get that milled there as well. We roughed it in on the old shaper, and even though it looks good, I really love that linear finish there. I wanted to finish this over on our CNC mill, so that's the goal for today and for this video. I've been working on a program for the mill, and I think I've got one ready to go. So what I'm going to do is go ahead and start getting our vices set up. We're going to use 2 milling vices to hold this section of the jaw. I've got our mill vices over here. We got a previous video of measuring 2 of these guys, comparative height measurements to make sure the bed heights were the same, and they are, and they all match there within a few tenths of each other. So we're going to take 2 of these mill vices and go over there to the Milltronics and get those set up, get them both trammed in line with each other, and start getting this vise jaw body set up. So I've got some ideas for maybe a very unique finish that we can put on this, but we'll see as we go. So come along for the ride, and let's see what we can do about getting this guy finished out. I did want to mention we've still got some other components to machine. We've got the tail portion right here that we got to machine. Got to get this side milled and drilled. This side here has got to be counterbored and milled on the inside, so we still got that to do. And of course, we still got to get the inside of this machine. We're going to be doing that on the shaper there as well, doing some internal shaping. Once we get this milled and on size, then we'll set this guy up and go ahead and machine it, hopefully to match this size right there. I'm also wanting to play around with these guys. This is the spindle that comes with the Hardtail Vise. I would like to see about machining my own spindle just to make some a really good shop project and to share with you guys. I'm thinking that once we get to this, I'm going to use the manual lathe to cut our Acme, and then this meatball portion here would be a fun project to do using our CAD and CAM. So that's a project that's in mind. And I'd also, this is the nut right there. Kind of goes in just about like that. And I'd like to see about machining one of these guys there as well. Absolutely nothing wrong with these parts right there. And Jason over at Fireball has already proven how strong all these components are. But I thought it would be great to make really good shop projects to build these 2 components myself. So that's going to be some upcoming projects that I want to get to after we get our vise completed and get it all bolted together.
Gonna need that.
Go ahead and make sure all the chips are off the bottom here. Those things that we fabbed a few years ago to do some pulling with are pretty handy for lots of different applications. So we've got the right side vise trammed in nice and straight, but we want to make sure that this rear jaw, that everything's in line. I'm going to start off by dropping in this big boy parallel right here. This is one that Lance had dressed for me on his surface grinder, so we know it's pretty close to being flat and straight. And I wish it was a little bit longer, but this will still work. We're just going to kind of set it over here like that, so where it's sitting on both of the beds. I'll go ahead and tighten this guy up. This will help us get this vise really close, snug it in place, and then run our indicator across there, make sure it's straight and the jaws are in line. So now this one, it's still kind of floating, but I've got it positioned where I wanted, because what I was doing was going about 20 inches, which worked out perfect. So we got about 20 inches there of where we want to clamp. And this should give us, we're going to have the dynamic jaw flipped one side and also back. So once it's flipped back that way, I want to make sure that we've got enough clearance here that it doesn't crash into the back of the machine, which is going to be about 4.5 inches minimum. And looking down right there, we've got approximately 6 inches to the back of the fixture. Remember, on this particular mill, we can't hang anything over the fixture because it's really close to that guard once you go all the way back with it. All right, so we've got this vise about where we want it, side to side where our bolt holes are going to be for our clamps, studs, should I say. Now we'll go ahead and tighten this one up here. Just snug it up. Now that should be pretty darn close in line with this parallel. So now I'll go ahead and get our studs and flange nuts on there and snug them down, and then we'll sweep this to make sure it's indicated nice and straight. I'm using 1/2 inch studs there, and then I go on with these heavy duty washers. I put a 5/8 washer and then a 1/2 inch washer, and then flange nuts, which I didn't grab. Might have to get a socket wrench in there for that other one. You just want to snug it. We don't want it real tight, but we don't want it just sliding around freely. Yeah, there we go. All right, so now we'll go ahead and take our parallel out. It would help if you loosen this one too. And we'll get an indicator set up and start sweeping both of these together. We'll make this a little easier to sweep there. I like using the larger dials. I think it'll work a little bit better on video. But we have the large button tip on there so that you ain't got to worry about it crashing once it hits those edges. We can just use our fine adjust there to tweak that the way we want. X. Making sure it's not hitting the bottom there. So we are good to go. That one looks good. I'm gonna give it an initial sweep over here and let's see where we're at. I'll bring you guys along. Less than a half a thousandths off. Less than a half a thou. You gotta remember to take these vise handles off or else you risk doing something like that. I think that's gonna be close enough. We're not even gonna have to bump this guy, look at that. Maybe we will, okay. Half a thou low, half a thou high. Man, I don't even know if that's worth trying to mess with, but you know how it goes. Can't leave well enough alone, right? So let's see what we did there. We only moved it a half a thou. Nope. See, I made it worse there. I made it worse. So what I need to do is see if I can get that corner about on 0. Let's see if we can do that. Okay, that one's on 0. And let's see if we can snug this side right here because we want it to pivot there. So we're just using the hand control here. One thou. All right. Wow, okay, there we go. It's got a couple of tenths movement. Let's go ahead and sweep it all the way across. That's where that button tip really shines right there. Comes in on it. All right. All right, well, a 1 thou resolution indicator is telling us that we're probably within, I'm gonna say 2/10 of being completely trimmed all the way across there. I think we're good to go. So we're gonna leave them right where we're at. We need to go ahead and make sure that, we need to snug that down and make sure it doesn't move on us. I always do that, snug them and then check it again. I'll get both sides tight. We'll retorque all 4 of these. I'll give it one final sweep, make sure it's good to go. So we're going to use the magmate here to pick this up. This is a great use of the sky hook and why I got it, so we can basically transfer heavy work pieces like this from this area over here underneath the Gore bell crane. Just make sure that there's no crud or anything sticking down. And I'll try to get it as far down to that side as I can. I've never weighed it, but it's probably, I don't know, feels like 30, 40 pounds maybe. That thing will hold as long as it's flat. We got a good machine surface there. What I always have liked to do, especially when I'm picking up big plates on the floor or something like that with a magnet, once I get it up, I try to just jar it real heavy. If it's down on the floor, I'll take my foot and just kind of, you know, kick on it a little bit. And if it doesn't do it while you're manipulating it like that, it's not going to just drop off there unless something hits it. But those magnets are pretty strong as long as they're nice and flat. Obviously, just don't stand underneath it. Never stand underneath a heavy lift or any lift. Just swing it around this way right here. About like so. That'll work. That'll work beautifully right there. All right, before we set it down, I was going to show you. So I've got these parallels right here. These are for the chuck stop, the Edge Technology 5/8, and they all measure. They're all measuring 5/8, 625. But what these guys are going to do is, just like we did in the shaper, this is our machine surface right here. I don't want to rely on this surface. I want it both sides to be true with our register. So when we set it down, we're going to have these parallels sitting down there like that, so that we're sitting on this machined edge right there. So we'll have a couple of these on both vices there and set it down, and then we'll use a piece of rod stock on the other side so it can pivot as it tightens up and get it all squared up. Nice. All right. Thing gets heavy with all those counterweights on it. All right, we got our little parallels here, 5/8 height, jaws, everything is nice and clean and wiped out. And we're going to put these on the inside on your moving jaw here, because the first side that I want to start with is the side that's going to be, we're going to be looking down here. Our dynamic jaw is going to be back here. That's the one that I want to start with. And when we do that, we'll rotate 180 degrees. We'll have to move these parallels to that jaw back there. That's what I was afraid of. It's all the way back, so we're gonna have to just kind of push it that last little bit. All right, we got her in there. Pretty close, but it worked out. We've got our jaw clamped in there. I realized that I did not need the rod that's going to be on this front side right there. I was thinking, like when we put it in the shaper and it was still a rough cast, you need to have something, a round rod in there for it to square up. But both the bottom and the top side are machined square. We did that on the K&T mill by clamping it down on that machine surface. So that should be, I would say, within a couple of thousandths of being square. All right. I've got a number 671 right angle attachment made by Starrett. We've got that attached so that we can indicate this little lip right there. You do the same thing with a test indicator, but like I said, I like using my dials. So I did an initial sweep and I'm showing 1.5 thousandths difference across there. I'm going to go ahead and move it on down to the other side. So we got 0 there and then minus 1.5 thousandths there on that end. I think that's going to be well within the tolerance that we need to machine this thing to. So I'm not going to fuss with that. I do have it bumped down, so it is nice and square on those parallels. And we're just going to let it run right there where it's at. Yeah, I think that's going to be good there. So I mounted up this work stop right here, and I've got this set so that we can, once we touch off on our X, this is gonna be our X0, and I want this to be our work coordinate for both sides, so that once we machine this side, we'll be able to rotate it 180, slide it back down against our work stop, and then this will be in the same location right there. We'll still have to, we'll have to touch off on our Y and our Z height at that point. So next thing we need to do is go ahead and get our probe set up and go ahead and find our G54 work location, get that done. We're going to get our work coordinate sets, our X, Y, Z, using our Renshaw probe. I love using this tool. It still fascinates me what all goes on behind the scenes of this software whenever you're touching off a work surface. So I love doing it. I love showing it with you guys, sharing it on the videos. So we're going to touch off our Z work offset is going to be this work surface right here, or this surface anyway. I've got this machined within about 1/1000th of being the same distance to both sides. Now what I will say is that this surface and the opposite surface there, which we did on the shaper, is not 100% parallel from end to end. You have 5/1000ths variation from one side all the way to the other. All right, and that was just with my setup there on the shaper. My intentions here, now that we have this register fit here that we're using for our alignment in this plane, you know, we already showed that we're 1.5 thousandths. So I'm fine with that because we got a tolerance there that we're going to be machining this to, and then when we machine the body that this slides to, we're going to have a few thousandths clearance in that as well. So we'll touch off on our Z, and we're going to machine that, and we should have 70 thousandths or there and about within a couple of thousandths on both surfaces that we're going to be machining. So what I was getting at, Z is going to be off this surface right there. We're going to take 70 thousandths off of that, and then our X is going to be on this end down here where our stop is at, and then we'll use Y is going to be obviously in the middle right there. Probe, single surface, Z axis is what we want. G54 offset, Z distance to part. So we're just eyeballing that. I'm just going to say negative 0.3, and our Z position is going to be 0. So we're ready to run it and hit cycle start. Okay, Z is established. Now we'll go ahead and come down here and do our the X dimension here on this end. Okay, we're going to go back into probe, cycle, single surface, X axis, X distance to part, and let me make sure I'm going to be going the right direction. Sometimes I get hung up on that. We're going to do 0.3. All right, we're moving that way. It's plus. We're going to the left is plus, so we're going to do 0.3, X position 0. The probe must be positioned to the Z depth that probing will be done. So we should be there. I'm going to slow this down a little bit and let's run it. If I went the wrong direction, we'll know it right away. And I went the wrong way. So I'm still trying to remember the proper directions, plus and minus. And when you're not used to the CNC stuff, it takes a little while to remember everything. You guys, I'm sure, are fully aware of that. All right, so we're going to go back in the probe, single surface, X axis, and right here, distance to part. So I've got to go negative 0.3. We want that to be 0, and it is positioned where it needs to be. So it should work this time. Let's try it again. I'm going to hit run, cycle start. All right, we got it. We got it that time. Go to our Z and bring the probe up. All right. Y. X, should I say. Really, it doesn't matter where you do this Y touch off. We could have done it right here. It would have been just fine. My mind said, you know what, let's take it to the middle. So that's what we did. All right, let's set up to touch off in Y. So in Y, I usually use my hook scale and just kind of eyeball the ruby there to the center of it. And now we back into our probe cycle, and I'm choosing web, and we're going to choose Y-axis there. All right, the width of there where we're going to be probing is 4.8. G54, we want our Y position to be 0, which is the middle. And we don't need any extra depth. The probe must be positioned -3 above the web. So we are ready to run it. Slow it down to 50%. Hit cycle start. All right, great. So we've got our work coordinates set up now, X, Y, and Z for G54. I think we're ready to run it. Before we get started, I'm gonna give you guys a quick little preview of the program in Fusion 360, kind of show you what we're gonna be doing. Let's go in there to the computer. All right, guys, I got you in here at the desk. I wanted to run through this quickly and show you what the machining program is gonna look like. All right, so there's our model right there of our jaw. As I mentioned, I didn't include all the other section out here. I just didn't see the need for trying to draw all that. But that's our main body. You can see the triangular portions there of our stock. So the way that I wrote the program is that we're first going to come down with, we're going to be using a 2-inch face mill, and it's going to go ahead and try to rough a little bit of this out using the parallel pattern. And then it'll do a 2D contour, which will take a swipe across that. And then it's going to start working on the parallel tool path there to cut all of it down flat. And then it's going to do another 2D contour across there to clean that side up. And then back to another parallel program. That will be the second pass on there, which should actually be the finish across it. Another 2D contour to finish that angle out. And then we're going to the extra little special program that we wrote in here, and that is going to be the trace program, so I can add my Ep.79 logo there. Let me go ahead and see if I can get you lined up so you guys can see this, and we'll turn this sketch on, and there it is. So I wanted to definitely add my logo somewhere on the vise, and the more I kept looking at it, I thought that this would be a great spot to do this. This is a big machine, flat surface. Great place that we can finally engrave a nice big Ep.79 logo on there. And so that's where I chose to do it. My thinking of where I actually wanted to place it, let me explain that to you. So normally when you're using a vise, everyday use, you're what, maybe, open it up anywhere from 1 to 4 inches possibly. Always, of course, depends on what you're doing. So you're not always opening the vise up 6 inches or more to hold a workpiece, depending on your work. So I was thinking most time you'd only open it up a little bit, hold something, do your work, and then you take it out. Whenever you're opening it up just a few inches, I didn't want to start seeing this logo appear out here, right? So I've got it so that you can open up the vise 6 inches, that's this distance right here. It'll open up 6 inches before you start getting into the logo. And then if you want to see the entire logo, you got to open the vise up 12 inches to see the whole thing. That way it's kind of hidden in there and it's just not always visible. I didn't want the vise partially open and you're just seeing a portion of the A and the mic body right there sticking out of it. So I kind of wanted it tucked away so that it's not always out there hanging out with a partial view of it. We did add the machined by at the top and then the year 2024 at the bottom, and I did that because I just wanted to signify that I machined this guy, I built it, put it together, and we wanted to remember that it was the year 2024 whenever this happened. All right, so we'll do a quick simulation of everything so you guys can see what this program is going to look like. We'll go ahead and simulate it now. All right, there's our 2-inch face mill. Working on the parallel tool path. Then we're going to do a 2D contour on the end. Back to a parallel tool path. This will be our finish. The green color indicates your finished stock. One more 2D contour. Then the trace program. And then we're going to do a 2D chamfer around 3 sides of it. And that's it, finished out. Once this is all completed, we will loosen it up and we will rotate it 180 degrees to the other side and we'll finish it out. But I wanted to start with this side so that you guys can get a clear shot of the engraving program that we're putting on there. So I've actually got the tool set for the engraving. I've got it set to a 1/1000th depth of cut. I think that might work out pretty good. We use a number 2 solid carbide center drill for that. And we'll make a pass across there, see how the logo looks. If we need to go any deeper, we can certainly modify it, change our Z height, and come down and make a second pass if it's needed. So let's go ahead and see if we can make this job happen. This is our face mill that we're going to be running today. This is a 2-inch Tungaloy quad mill is what they call it. 8-sided insert. I just went ahead and indexed them all around because I have used it quite a bit and it looked like that maybe a couple of the corners could be indexed, so we went ahead and got all fresh corners on that thing. This is an SNMU insert, by the way. The high end of the surface speed they recommend for this grade is 660 surface feet per minute. So we've got the program written to run at 650 surface feet per minute. And I'm kind of like right in the middle of the chip load. It's rated anywhere from 2 thousandths to 12 thousandths per 2 chip load. And I've got it set to cut at 6 thousandths per chip, 6 thousandths per tooth. My idea was, you know, we get through the first tool path across it and I can kind of pause it and see what the finish looks like. And then everything looks good. Hopefully it will be. We'll just continue on and it'll finish it out. So I didn't want to run it across there too fast because I want a decent looking finish on this, but I don't want to take too long where it takes forever to get it machined. But this does work really good. It's a nice heavy duty robust insert, and with the 8 corners these inserts usually last you quite a while. So we'll get her loaded up and see if we can get started on it. So the way I usually start this is I change my coordinates for our Z offset up a little bit higher, so I've got it changed to 1 inch so that I can watch the tool path and make sure everything looks like it's going to work pretty good. I actually had to make one correction. That's another benefit of doing that. I had the wrong tool number selected for the face mill for the very first stop, and the reason why is because when I first started doing that, I didn't have that tool ready, and I selected just a random tool out of Fusion 360 for a 2-inch face mill, and I forgot to change that one back to tool number 11, which is what that one was. So when I first started, it pulled tool number 1 out, and I said, this isn't the right tool. So I went back in there and saw what I did, modified it, re-uploaded the program, and I think everything is good now. So I'm going to go ahead and we're going to hit cycle start. It's already got tool 11 loaded, and it's just going to bring it to 1 inch above our finish of what our Z is actually set at for our work coordinate. And we'll just walk through briefly our tool paths here. And since I've already watched this one time, I know everything is going to go pretty well. We can go ahead and kick this on up to 200%. It'll speed it up just a little bit. This has been a great way to test these programs before you actually start cutting metal. You know, something that I remember Steve Sherman taught me right at the beginning whenever he was giving me my first lessons on the mill, is to just change your coordinate on your Z, test it out in air. And you can kind of visually see where that cutter is. Like when we first started, I was lining up the cutter with that, you know, channel there. It should come just to the edge of it, and it does. engraving program. Everything looks good, but we got to just get on the program and make sure it's going to be on the right depth. But like I said, we can adjust this height if we need to. Chamfer is going to be the last stop. We've got this set up to 8,000 RPM, which is the max RPM of the Milltronics here. That'll be our actual cut speed, so we'll speed it up 200%. In the program. Let's go ahead and adjust our Z. We'll go ahead and do that right now. So I'm ready to get started on this. We're going to exit, and we want perimeters, chords, and then this is our Z coordinates. We're going to change this Z to 0, enter. Now we should be ready to go. Go back into our run program, and we're ready to start it and hit the button. All right, so what I'm gonna do, I'm gonna load you up on the spindle up here and give you a shot, and just keep the camera running the whole time, because I wanna have my hands out here on the controls and not fussing with the camera while we do this. We have one shot at this on getting this right, and I hope we got it right out of the bag here.